In this video, we're going to be doing lesson 4-6, where we look at rational numbers. So let's start off by defining what a rational number is. A rational number is any number you can write as a quotient a over b of two integers where b is not 0. So what that means is it's any number that can be written as a fraction of two integers where the bottom of the fraction isn't going to be 0, because you can't have something over 0 in a fraction. It doesn't work. So over here we have a circle that kind of explains the different types of numbers. So in the center we have 75, 0, and 3 over 3. Those are whole numbers. Okay, we know something is a whole number when it has no decimal and no negatives. That's how we're going to define whole numbers for this. So no decimals and no negatives. 3 over 3 is the same as 1, right? So it has no decimals and no negatives. Okay, so that's these numbers here in the middle. Then the next one is kind of like an overlayer. So like this next one really is this whole section. So it includes the whole numbers, but it includes these other numbers as well. So it kind of like builds up, okay, to contain both. So those are going to be called integers. Okay, we know something is an integer when there's still no decimal, but it can be positive or negative. So we have -1, okay, -7 over 1, -12 over 6, which if we divided that would just be -2, right? And -103, as well as still 75, 0, and 3 over 3. So none of these numbers here in the middle within that bigger circle have decimals, and they are either positive or negative, and either one is fine. The last layer, this outer layer, which contains all of those as well as the inside ones, are called rational numbers. Okay, so rational numbers are any two integers, okay, that can be written either as a decimal or as a fraction of those two integers. So basically any other kind of number. It can have decimals, it can be positive, it can be negative. Any of those things are fine for rational numbers. Okay, so this first part says to write two lists of fractions that are equivalent to 2/3. They want us to write some that are positive and some that are negative, but that are still equivalent to 2 over 3, which is a positive number to begin with. So in order to do that, let's start with the positives. So they went from 3 on the bottom to 6 on the bottom, which means they did times 2 and times 2, because you always have to do the same thing to the top and the bottom. So the top of that is going to be 4 over 6. Then they have something on the bottom that's 9, right? So that means that they took 2/3 times 3 times 3, because to get that 9 on the bottom, they would have times by 3. And again, you need to do the same thing on the top and the bottom, so you're going to end up with 6 over 9. So 2/3 is equivalent to 4 over 6, as well as 6 over 9. They want also to have some where the numerators and denominators are negative. So how do you make negative numbers into a positive fraction? If we have -3 on the bottom and we put -2 on the top, by having a negative divided by a negative, we're going to end up with a positive final answer. So if we took 2 over 3 and we divided it, we get like 0.666666 and so on. If we took negative 2 over negative 3, we would get positive 0.66666 and so on, because negative divided by a negative is going to be a positive. So if the first fraction is in positive and you're trying to give it negative equivalencies, you have to have a negative on the top and the bottom. All right, so then they also have negative 6 on the bottom, so we would put negative 4 on the top, because that's really 2 over 3 times negative 2 times negative 2. Okay, so 2/3 is equivalent to 4 over 6, 6 over 9, negative 2 over negative 3, negative 4 over negative 6. All right, so let's look at another example of this. So let's do A together. So we have 1 over 3. So we're going to make 3 fractions that are equivalent to each of these. So the first one that's easiest to do, we have 1 over 3, which is positive. Let's write that using the same numbers, but negative, right? Because we could say negative 1 over negative 3, and we get the same thing. Again, if you divided 1 by 3, then you would get 0.33333. If you divide negative 1 by negative 3, you also still get positive 0.3333. So those two are equivalent. We can also do ones where we're multiplying. So we have 1 over 3, let's say times 2 times 2, and we're going to get 2 over 6. Okay? Then we could do our negative trick again, which means we also could say negative 2 over negative 6. So 1/3 is equivalent to negative 1 over negative 3, 2 over 6 because we did some math, and negative 2 over negative 6. So using that same type of pattern, I want you to do B and then stop. Okay, do B and then stop. So pause the video while everyone tries that. All right, so using the same pattern, what we could have ended up with is negative 5 over negative 8, because we had that positive 5 over 8 as our beginning fraction. We could have done 5 over 8 times 2 and gotten 10 over 16. And then we could have also had negative 10 over negative 16. And all three of those fractions are equivalent to 5 over 8. All right, we're going to do C together because it's a little bit different now. So this time, the negative is on the outside. So because of that, we can't do our negative on top and negative on the bottom trick, because then we get a positive answer, right? But we can specify that the negative either goes with one of the numbers or with the other. So since they have it out in the front kind of floating, we could be like, well, really, negative 4 over positive 5 is equivalent to negative 4 over 5 when the negative is out in the front. All we did was specify which one. We could also say 4 over negative 5, okay, because again, they had the negative out in the front, and we're just specifying top or bottom so that we end up with a negative divided by a positive or a positive divided by a negative, which both of them would give us that negative answer. We can also, so like let's say I took negative 4 over 5 times 2 and get negative 8 over 10, right? Or we could have 8 over negative 10 if we had done 4 over negative 5 times 2 times 2. Okay, so all of these end up being equivalent. So when there's a negative in the front like that, you have to choose either the top or the bottom. When there's no negative and it's a positive, you have to do both in order for them to actually be equivalent. Because this, when you divide negative by negative, is going to give you a positive. This, when you divide negative by a positive or positive by a negative, is going to give you that negative that you need. Okay, D is the same kind of pattern. So go ahead and try D on your own. Pause the video, and then we'll do it together. Okay, so hopefully you had something similar to negative 1 over 2, 1 over negative 2. Let's say I did negative 1 over 2 times 2 times 2, and I got negative 2 over 4. Or you could have done 1 over negative 2 times 2 times 2 and gotten 2 over negative 4. Right, so all of those would end up being equivalent to that negative 1/2. When you're ready, go ahead and flip over your paper. Another part of this lesson is looking at putting things onto a number line. So they give us 4 different choices or 4 different numbers, excuse me, that need to be added to the number line below. So first things first, we have 0 here, we have negative 1, and we have 1. The first one says negative 3/4. So if we look, this is already broken into 1, 2, 3, 4 spots, right? So that means that to get to negative 3 over 4, we go 1, 2, 3. I guess I could use a different color for that. And this is going to be negative 3 over 4 because there's 4 spots and we've gone 1, 2, 3 of them out of the 4 to get to 1. Okay, so that's negative 3 over 4. 0.5 is really the same as the number 1/2, right? So where is halfway between 0 and 1, since this is positive? Okay, 0.5 is right there in between 0 and 1. Then they want us to mark where 0 is, which is kind of silly, right? Because they already gave us that, but this is 0, right in the middle of our number line. And then they want us to do 1/3. 1/3's a little tricky because they don't already have the lines drawn for us, so we are going to have to add our own lines. So essentially what you want to do is you want to think about the fact that 3 over 3 would equal 1. You can do this with any number. Take the denominator, make it the top and the bottom so that you know how many pieces you need. You're going to need 3 pieces between 0 and 1. So then, if I were to make my own lines, something similar to that, where I have 1, 2, 3. Those do not look even, Miss Keel. Let's try again. 1. There we go. That looks better. 1, 2, 3. There's now 3 sections. 1, 2, 3 sections, okay, that I've made. They want me to go 1/3, which means that one section, 1/3. This is 1, 2, 3. So this is 1/3 because it's 3 set pieces, and I'm only going one of those pieces before I put my line. Okay, so 1/3 is going to be like that. So anytime you have to make your own, you can just figure out based off the denominator how many pieces you need. We'll get to try that again down at the quick check if that's a little bit confusing still. Okay, the last piece is going to be kind of plugging in numbers into equations and just solving them using math skills that you already have. So it's just making sure that you understand how to plug them in. So a fast sports car can accelerate from a stop to 90 feet per second in 5 seconds. What is its acceleration in feet per second? Use the formula, and they give us a formula here. A is the acceleration. F is the final speed. I is the initial speed. And T is the time. We have most of those things. It says, what is the acceleration? So that's the thing we don't know. Final speed, we go from a stop to 90 feet per second. This is where we start. This is where we end up. So the final speed is going to be 90 feet per second. Initial speed, if we're starting from a stop, is going to be how many feet per second? 0, right? 0 feet per second. And then time, they said it takes 5 seconds. So all we have to do is for those letters, plug in those numbers. We don't know A, so the A stays the same, right? Because we don't know what the acceleration is yet. F, they said, was the final speed. And F is right here, the first number. So we're going to put a 90. Minus I, which was the initial speed, which was 0 on ours. Over T, which is time, so we just put a 5 on the bottom. So that means then we're going to just solve it. 90 minus 0 is 90 over 5 is the acceleration. We can simplify that. So this just means divide, right? When they're written like a fraction like that. So 90 divided by 5 is 18. So the car's acceleration is 18 feet per second squared. Okay, so again, you're just making sure that you're plugging things in based off of their letter from this formula and then solving it the way we've been doing solving. All right, so let's look at the quick check here. All right, it's another number line. So we are adding -1/2, -4/10, -2, and 0.9. I'm going to have you pause the video and go ahead and try and do these yourselves, remembering that the 10 is going to be a clue, like between 0 and 1, you're going to need 10 lines, and then you're going to go over 4 and so on. Same with this. This is really like 9 over 10, right? Pieces. So I want you to try them. If you get them wrong, you can always just erase them when we go over it together. So go ahead and pause the video and try to put all 4 of these on this number line. All right, so let's go over these ones together. So I'm going to add some numbers it doesn't ask for just to make our lives a little easier. I'm going to add -1 and 1 since this one skips to 2. So since -2 was 4 over, that means that -1 would be 2 over because that's halfway between 0 and -2. 1 is going to be halfway between 0 and 2, so it's going to be on this middle line. Okay, so -1/2. -1/2 is going to fall between 0 and -1, right? So -1/2, I'm going to do this one in red, is going to go right here. Okay, halfway between 0 and -1. -4/10. So I'm going to zoom in a little bit so you can see what I'm doing. -4/10. So between 0 and -1, we're going to need 10 spots. So I'm going to draw that. 1, 2, 3, 4. This one would be 5, 6, 7, 8, 9. This one would be 10. Okay, so to go -4/10, I'm going to make this one purple. -4/10, I'm going to count over 4 lines. 1, 2, 3, 4. So right here is going to be -4/10 because I did 10 sections between 0 and -1, and then I counted over -4 of them. Okay, again, they had kind of a silly one that was like one that's already written. -2, everyone should have gotten that one right. That's -2. And then the last one was 0.9. So again, between 0 and 1, you're going to need 10 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And to get 0.9, we need another color. 0.9 is just going to be 9 of them over. 0.9 is orange. Okay, so if you got those wrong, just erase them. You guys can pause the video and leave that up. Erase them and fix them. Okay, keeping in mind that you need like 10 spots to help you make -4/10, 10 spots to help you make 0.9. All right, when everyone's ready, we're going to move down to plugging in and solving. Okay, so we're going to do A together. So they give us, for each expression, wow, can't read, Miss Keel. Evaluate each expression for A equals -6, excuse me, and B equals -5. So that means anywhere there's an A, we're going to put a 6. Anywhere there's a B, we're going to put a -5. So for this first one, we're going to rewrite it. It says A plus B over -3. So we're going to put a 6. Ooh, I don't want orange. A 6 plus a -5, because we had A plus B over -3. Okay, then we're going to start by solving the top. 6 plus -5 is really just 1. And then -3 stays the same. And that's our final answer. Okay, so you're just plugging in what they are. Okay, I'm going to have you try B on your own. Remember that when they're written right next to each other like this really means 3 times A. When you have a number next to a variable, it really means to multiply. So when you plug in your number, you're going to have 3 times whatever you would put for A. So go ahead and pause your video and try B and C, and then we'll go over them together. All right, so for this one, let's plug it in. So we have 7 minus, then we put in a -5, right, for that B, over 3 times 6. So let's solve the top first. 7 minus -5. Remembering that when we have minus a negative, we're really adding, right? So -7 minus a -5 is really 12 over 3 times 6. And then if we solve that next part, 3 times 6 is 18. So if we have 12 over 18, remember this last piece of the instruction, where it says write it in simplest form. Is 12 over 18 in simplest form? No. Okay, so if we divide the top and the bottom by 6, I'm going to come up a little bit, we end up with 2 over 3, right? Because we divide 12 divided by 6 is 2, 18 divided by 6 is 3. So our final answer ends up being 2 over 3. All right, for this last one, we have 6 plus 9 over -5. Because again, I plugged a 6 in for the A, -5 in for the B. 6 plus 9 is 15 over -5. That's not in simplest form because we could simplify it. Or we could just divide the top by the bottom, right? Because we know that 15 divided by 5 is going to give us a number. So that's probably the easiest way to do it. So 15 divided by -5 is just going to give us -3. If you simplified it, like if you did 15 over -5 and you did divide by 5, you would have gotten 3 over -1, which is the same thing as -3. All right, that wraps up lesson 4-6, where we are looking at rational numbers.